This is pre-calculus. We're doing some Algebra 2 review, 9-10. There's that. Let's talk about our general formula. So, all the way back, tons of review. General formula. What does A do?
The amplitude.
It's the amplitude. Label it in your notes. Amplitude. And while amplitude is always positive, A can be negative. For example, if you go to a minimum instead of a maximum first, your A will be negative. All right, B, what does B affect?
Period.
Period. And what is the formula for period?
2 pi over p.
Yeah, so B is equal to 2 pi over P. Nice. And B will always be positive. I mean, you can have a negative number. You can plug it in there, but normally for us, it's always going to be absolute value of P.
So you're teaching us wrong.
I guess I'm teaching you wrong. I'm teaching now correctly, though. H. What does H do?
Nothing.
Well,
I'm just kidding.
it
Moves
does.
whether it's going to be like on the right, the left.
It moves, yeah, we'll just say an arrow. It does a horizontal shift, so it does this to the function. And what does K do?
The midline.
K is the midline. Or if you want to be fancy, you could say it moves your function up or down. It is the vertical shift. This is the horizontal shift, the H. Nice. All right, relabeling our graph, just again to make sure we know what we're doing on the same page. What is this right here?
The amplitude.
That's the amplitude. What else do we need? What is that line right here? This dashed line right here is called the
Midline.
midline. And I should probably be labeling these in the correct color. All right, so this is going to be midline here. And I want to change this to amplitude in blue.
Teacher hard at work.
All right, what about the period? Period is in the X or the Y direction?
X.
X. So how much is this? How much of the period is that?
1/4.
1/4. How much of the period is the midline to the midline?
1/2.
1/2 of the period. Other things that I want to know. What function starts at the midline? What function, sine or cosine, starts at the midline?
Sine. No.
What function starts either at the minimum or maximum, depending on your amplitude being positive or negative, but starting at an extrema, what is that?
Oh, you're talking to me?
I hear Rochelle whispering it to Daisy. It is cosine.
Good. I already said sine, so I wanted you to say cosine.
Yeah, that way you can go back and forth.
You were talking to me or no, you weren't.
All right,
Oh,
so
I just wanted you to say it, okay?
It's okay.
Helpful.
now we will begin on example 1. We have a lot of reading to do. Who is our beautiful voice to read this? Daisy or Rochelle?
Thank you.
All right, Rochelle, thank you.
What?
A pendulum.
A pendulum is swinging next to a wall. The distance dt in centimeters between the bob of the pendulum
Pendulum.
pendulum
There you go.
and the wall is a function of time t in seconds. Can be modeled by a
Sinusoidal.
sinusoidal
Good enough, yeah.
expression of the form a times sine times parentheses b times t plus d at t equals 0 when the
Pendulum.
pendulum is exactly in the middle of its swing. The bob is 7 centimeters away from the wall. The bob reaches the closest point to the wall, which is 1 centimeter from the wall. 5 seconds later, find dt. T should be in radians.
Yeah, and I guess I probably put too much G sounding in here, but pendulum. I think people pronounce it both ways. Or maybe I just pronounce it wrong. Pendulum. Sounds pretty close. But yeah, so you have this weight. This weight is swinging.
Pendulum?
It's a pendulum, yeah. Pendulum.
Yeah, okay, whatever.
But it's something that's swinging back and forth. Like your arms swing when you walk, right?
Yeah.
So the end of the pendulum is the bob. So it's like your fist. Your fist is the bob. And it already told us that it's going to be a sine function. Pretty nice of them. We don't even need to figure out the parent function. So now we know that the pendulum is exactly in the middle of its swing the bob is 7 centimeters from the wall. So middle of the swing, we have to somehow translate that. Middle of its swing. What do we think is happening on our graph? Is that kind of a midline and extrema? What do we think? We're saying middle of its swing. Where are you on the graph? Are you at the... So I already told you it's a sine function.
Oh.
But are you at a midline, an extrema, a minimum, a maximum? Where are you?
It'd be midline.
What do you think, Daisy?
Yeah.
Yeah, it is a midline. So we can just write above this is the midline.
I mean, it does kind of say.
Middle, yeah, it's kind of a dead giveaway, right? So the middle is 7. There it is. And then the bob, again, that's like the end of the pendulum, reaches its closest point to the wall, which is 1 centimeter away from the wall, 5 seconds later. So that's a little bit difficult to think about because our function d is the distance between the bob of the pendulum and the wall. So as the pendulum gets closer and closer, I guess I should say the bob of the pendulum gets closer and closer to the wall, the value of d is getting smaller because, and you should think about this, so as I am the pendulum, this is getting smaller and smaller and smaller and smaller. Now it's getting bigger and bigger and bigger and bigger because it's the distance between the bob and the wall. So it's getting smaller and smaller and smaller, bigger and bigger and bigger. Can we visualize this going?
So the bob is the maximum and the wall is the minimum.
So it'll be a maximum out here, it'll be a minimum right there. All right, so now we have to figure out, is this a maximum or a minimum? It is, so when it reaches its closest point to the wall, is that a maximum or is it a minimum? Minimum. Why is it a minimum? Try to explain it in your own words. Why is it a minimum?
Because it's saying it's getting smaller and smaller, and the minimum is always the one that gets the lowest.
Yeah, that's a good way of explaining it. So we're going to say that that is our minimum. Our minimum is 1 centimeter from the wall, 5 seconds later. So our minimum, if we were to convert that to a point, the x-coordinate is the time. So it would be 5 seconds later, 5 seconds, comma, and it's 1 centimeter. What about our midline? How do we convert that into kind of that coordinate pair? It says at time equals 0, so 0 goes on the x, okay, 0 seconds.
Sorry.
And then, Daisy, what am I going to put here? At 0 seconds, say it again.
7 centimeters.
7 centimeters, there it is. So we have our 2 points, just like our last lesson in lesson 9-9. But now it's a word problem. We converted this word problem to say the midline is at 0, 7, and the minimum is at 5, 1. We have now converted this word problem into a problem that we're familiar with already. And we already know that it's going to be a sine function. So let me go ahead and just write that now. I'm going to write it out here because I might need a big amplitude. I don't know what's going to happen. So sine of something. I know there's going to be an x in there. Oh, there's not an x. It's a t. It told us a t instead of an x. Sorry about that. It's a t. All right, now I have to find all these letters. I need to find A, B, and D. They have different letters than we do. So A is going to be amplitude. B is going to be the period. D is, we used to call it K, I think. Now they're calling it D. That's okay. All right, which one do we want to find first? A, B, or D? You can choose. Doesn't matter. We'll find
D.
D. D is what again? Is that
Midline.
midline? Okay. So midline, what is the midline, Daisy? We already labeled it.
7.
7. So we're going to say plus 7 here. And I can write this in red. We're filling this in. Plus 7. Good, good. All right. What's our next letter that we're going to be finding?
A.
Let's find A. A is what again?
Amplitude.
Amplitude. How do we find our amplitude from this one?
From the distance from the midline to the maximum?
To
Or
the
to the minimum.
minimum. Yep. So the distance is what, Rochelle?
It's gonna be the last one, which is okay. So it's gonna be 6.
6, yeah. It's from 7 to 1, which is a distance of 6. And now, I know that it's going to be a 6 here, but my
It's a
question for...
negative.
Oh, you already spoiled the fun. It's a negative. Why is it a negative, Daisy? I know Rochelle knows because she gave me the answer.
Because it's coming from the midline to the, midline to the minimum.
Yeah, to the minimum. If it was a maximum, then it would be...
Positive.
Oh, you're yeah, you guys
See,
are
I'm
on it.
learning.
No, you are totally learning. Yeah.
No, just.
All right, and our last letter, B. What does B affect, Daisy?
Period.
Period. Okay, so what is our period? How are we going to find that?
to the minimum, but through the x-axis
Okay, so how far did I go between 0 seconds and 5 seconds then?
by 5.
5, okay. And then,
you multiply it by 4 because it's from midline to minimum.
yeah, it's from a midline here to a minimum. From this spot to this spot, which is only how much of the period?
1 over 4.
1 over 4. So you multiply by, again,
4.
4 to make it a full period. Okay, so we're going to multiply this distance. This distance is, you said, 5 seconds times 4, and that is how many seconds? 20. So we can actually write that down here. We can say that the period, what color are we doing period in? I think it's in green. The period is 20 seconds. We got that, again, because we knew the distance in the x-axis from 0 to 5 is a distance of 5. We multiplied that by 4 to get 20. We multiplied by 4 because this was only 1/4 of the period. Okay, and now we're using our formula up here that you gave me, 2 pi divided by period, to get the value of b. So
it would be pi over 10.
Pi.
Or you could do 1 over 10 pi.
Over 10 or 1 over 10 pi. Yeah, I agree. Both of those are correct. There's our answer. And we're going to box it. Very nice. All right, so I just want to add this note. You already know this at the very bottom. If the sinusoidal function starts with a minimum or starts to head to a minimum, then what do we know about the amplitude? Then the amplitude is what? Does Daisy know it as well? Yep.
It's a negative.
Is negative, yeah. So if I start at a minimum, that means I have a negative cosine. If it heads to a minimum, that means I have a negative sine. Cool. Let's look at example 2 on the back. I already heard the papers flip over. All right, Rochelle read the last one. That means it's Daisy's turn.
Jupiter's distance J of T in a... Wait.
Yep, J of T.
Did I say that right?
Yep, you're
Oh,
good.
okay. In millions of kilometers from the sun as a function of time t in years can be modeled by a sinusoidal.
Sinusoidal.
I can't say it.
I know it's hard. Sinusoidal.
Sinusoidal.
You're good.
Expression of the form A times sine B times T plus D. At year T equals 0, Jupiter is at the average distance from the Sun, which is 778 million kilometers. In 3 years, it is at, the closest point of the Sun, which is 741 million kilometers away. Find J of T. T should be in radians.
Yep, it's in radians. That means our formula is 2 pi over p instead of 360 over p. That's the only thing that we need to keep in mind. And everything, I think, will be in radians for our problem set.
Will we always do 2 pi in radians anyways?
Yeah, if it says radians, you're always with 2 pi. If it says degrees, which it won't for the homework set tonight, it's going to be 360 instead of 2 pi.
Will we ever do degrees?
In your life, yes.
Okay.
In this unit, no. Because radians are just so nice. All right, so what is our parent function, Daisy? What is our parent function?
Oh.
Read that problem again. Look for, it tells you what it is.
Oh, it's going to be sine. Sorry.
Yep, you're good.
I was
Sine.
like, wait, what am I looking for?
And we have a t in there. All right, what do we want to find first? Oh, maybe we should dissect this problem before we actually start finding things. So let's look at this first sentence. At year t equals 0, Jupiter is at its average distance from the Sun, which is 778 million kilometers. How do I convert that into a point, a coordinate pair? Something, comma, something. Time usually goes in the x-coordinate.
Can we do one? Do I have to do it in order?
It has to be in the correct order, yes.
No, I meant like as in. Never mind.
Oh, like
So
in terms of going back and forth?
Yeah.
It doesn't matter.
So it's 0 and 778, and the other one would be.
Oh, do you want to give that one to Daisy? All right. So from this first sentence, we have discovered that the first coordinate is 0, 778.
Oh, so then the next one is 3 and 741.
There it is. All right, now the next question is, what are these things? Are they midlines? Are they maximums? Are they minimums? Let's go ahead and interpret. I want to give Daisy the first one and then Rochelle the second one. So Daisy, you're up first. This 0, 778, at time equals 0, it's 778 million kilometers. It says it's an average distance, and that's our key. So what is this thing? A min, max, or midline?
Average distance. So that would probably be midline.
It is a midline. Let's go ahead and label that. And then Rochelle, you're up next. 3, 741. Is that a midline, a minimum, or a maximum?
Minimum.
Minimum. Why'd you say that?
Because what I see is that 741 is less than 778, which is the midline, which is under, so it's a minimum.
That is a great way of doing logic. 741 is indeed less than 778, therefore it is going down. It is a minimum. Yep. And another way of seeing that is it tells you that the distance from the sun is how we're looking at this function, and the distance is closest. So if we're closer, that means we are going to a minimum. So there's a few different ways of getting that.
I have a question.
Yes, I have an answer.
So it says at year t equals 0, Jupiter is at its average distance from the sun. How do you know that's the midline?
So midline is average distance. So average distance, if I took the average of a sine function of all of the points, then it would be this line right here. And that's kind of a calculus level concept too.
Like to watch a lot of like seeing it on a graph.
How do you know if say if it's a maximum?
How is it a maximum? It will tell you that it's the farthest away, or that it is a maximum, or it'll be very explicit in the question. And if it's not, then I'll come over and help you. But it should be somewhere hidden in that word problem. So what are we going to find first? Which of these letters? A, B, or D? We need to find all of those.
Might as well midline.
Midline. Okay, help us out with midline.
It's gonna be 203.
223.
No, 23. My bad. 23.
How did you get 23?
Because it's look, that's the midline. I'm talking about the amplitude.
Oh.
Remember the amplitude.
So let's come back over here.
Thinking, I was like, wait.
You got 23 for the amplitude. How did you get 23?
Oh, negative 23. My bad.
How did you get negative 23?
Because the distance from the y-axis from the midline to the minimum.
Okay, so if you subtracted the 778 and then you do that minus 741, you get 23?
Yeah.
Okay.
That makes sense.
And then why'd you choose negative? Wait, I'm going to re-ask that. Daisy, why did she say negative?
It's because you're going from a midline to a minimum.
It's the same thing, yeah, just in a different wrapper, all right? Daisy, you want to do the midline for us?
What?
You want to do the midline for us, Daisy?
The midline is 778. Right?
It is indeed 778. And how do I find the value of B?
Period. So you get you get 3 times 4. So it's gonna be 1 over 2 pi.
3 times 4. You said 1 over 2 pi here. You're
No,
going...
sorry. 1 over 2 times pi.
1 over 2 times pi.
There you go.
Okay. How did she get that, Daisy? Analyze.
I don't even remember. I was like, wait, where did you get that?
Okay, so yeah, I'll do it slow.
Go for it.
So 3 is the distance from 0 to 3, the x-axis. Multiply it by 4 because it's from midline to minimums, which is 1 over 4 to get to the period. Get it? And so 1 over 4.
Yeah.
So you multiply by 4, that equals 12. You plug it into the formula, 2 pi over 12.
Okay, that makes a lot more sense.
Okay, so when I plug that into the formula 2 pi over
Also,
12, then...
it'd be 1 over 6 pi, my bad.
Okay, that's fine. Let's change this to a 1 over 6 pi. Put that in red. Or pi over 6 is another way of saying that. And there it is. So just knowing how to dissect this word problem to get these 2 points and knowing if they're a midline, a minimum, or a maximum, that is the new stuff that we're doing. You already know, once I have these 2 points, if it's a midline or a minimum or a maximum or whatever, how to build the function from there. So now we're just trying to figure out what those points are and then you're ready to go. Are there any questions before we end the notes? All right, that concludes the notes.